Day, everybody. It's great to have the opportunity to give this presentation on Earth Day. So I'm Sherry Lippiatt. I'm the California Regional Coordinator for the NOAA Marine Debris Program based in Oakland, and I'm joined by Hillary Burgess, who is the Monitoring Coordinator for the NOAA Marine Debris Program, and Hillary is based in Seattle. And so today we're going to give an overview of NOAA's Marine Debris Monitoring and Assessment Project. We'll share some analysis of our California data set and some exciting updates to the project and our database. So the NOAA Marine Debris Program was established in 2006 and designated as the federal lead on addressing the marine debris issue. Our program was reauthorized in 2018, and we recently received some new mandates from the 2020 Save Our Seas Act. And our mission is to investigate and prevent the adverse impacts of marine debris. And we're a team of about 25 people nationwide. And I always like to point out that we are non-regulatory and have no enforcement authority. So the Marine Debris Monitoring and Assessment Project, or MDMAP, functions as a network of individuals and organizations that voluntarily participate in the project. So before anything else, I just want to express gratitude to these partners and other individuals who have participated in the past. The project really, could not exist without them, and we are just incredibly grateful for their time and contributions to the project. And so the goals of MDMAP are to detect spatial and temporal variability in the types and abundance of shoreline macro debris, so items larger than 2.5 centimeters, according to material and item type. To facilitate and support a national network of partners that are working to address research questions or develop science-based marine debris policies. To provide tools and resources to partners to answer their own questions. Our data can be used to guide the development of new mitigation efforts and evaluate the effectiveness of existing efforts. And then last, participation in the program can foster stewardship of the environment and raise awareness about marine debris issues, while also allowing volunteers to have meaningful and hopefully also fun experiences in nature. And so this is a timeline of the project. So development of the protocol and testing started in 2009 and extended into 2012. In the midst of that was the tragic earthquake and tsunami in Japan, which created a lot of interest and concern about debris impacting the U.S. Pacific states, and also, created a real desire from partners to have a national shoreline monitoring program. So this is really when we decided to morph what was intended to be a tool for the research community into a citizen science program. We launched the project and our online database in 2012. And we were actually really surprised by just how much interest and participation there was, not only on the West Coast, but in other parts of the U.S. too. And so in 2016, we launched the Get Started Toolbox, which included training materials, frequently asked questions, a photo identification guide, and some other resources. Then in 2017, once we had 5 years of data, we partnered with the Ocean Conservancy and CSIRO out of Australia on a data analysis effort, which indicated to us that there might be some issues with the protocol and bias in the data set that we then rigorously tested through this protocol evaluation study in partnership with COAST. And so I'll talk a little bit more about that later. And then in 2019, we also took some time to better understand our participants' experiences, as well as the needs of our data users. So, there might be folks on the line who participated in that process. So thank you so much for taking the time. And then today, Hillary is going to share some updates on how we're integrating all of this information into the next phase of the project, which is launching now. And so here is a snapshot of the data set to date. We have 443 sites have been established in our database. Over 9,000 surveys have been conducted from 9 different countries and in 23 different U.S. states and territories. And then zooming into California, we have 68 sites that have been established, just over 2,400 transects submitted, and 173,823 items recorded. And so I thought it would be interesting to look at both the top 10 most common items in our California data set, as well as the bottom 10, or the 10 least common items of the about 45 items on our data sheet. And so again, the protocol specifies a size minimum of 2.5 centimeters. So keep in mind that we are focusing on macro debris. But the top 10 list here, you can see, has a lot of kind of common offenders. So there's a lot of single-use plastics, but there are also some metal fragments and other metal items, most of which actually come from one site near Eureka, which is interesting. The bottom 10 list, also not a ton of surprises, but it does include 6-pack rings, which I feel like have always had a reputation for being a commonly littered item, but aren't really that common. And also rubber gloves, which is interesting from the COVID perspective. But this data set is all time, so looking back to 2012. So it would be interesting to see if they're becoming more common. And then as part of an analysis we did for the PICES, which is the North Pacific Marine Science Organization, we looked at the relative abundance of these different categories of plastic items across all surveys in the state. So here we're looking at debris abundance as a percent of the total debris found in California MDMAP surveys. And so 57% of the items were plastic fragments, 11% were plastic consumer items, 6% plastic smoking related debris, and 5% plastic fishing related debris. So, this kind of tells us that a lot of the plastic debris was too degraded to be identified as a specific item, and there's about twice as much consumer plastic debris compared to either smoking or fishing. But it is, again, important to point out the size minimum and the fact that this is probably an underestimate of the amount of smoking-related debris because of that. And so the rest of the data I'm going to show is from the Greater Farallones National Marine Sanctuary. So this is, located off the coast near San Francisco. And last year, our group, along with partners from the Office of National Marine Sanctuaries at NOAA, published a paper looking at temporal trends and drivers of debris loads within two of our longer-term data sets from the Greater Farallones and the Olympic Coast National Marine Sanctuary. So in the Greater Farallones, we had 7 years of about monthly MDMAP surveys from 6 different sites. Shown here, you can see kind of this cluster. I don't know if you can see my mouse, but this cluster of sites up at Point Reyes and 2 here south of the Golden Gate. And so across over 1,000 transects, we saw an average of 203 items per 100-meter length of shoreline, and 91% of those items were plastic. And so for this paper, the analysis we did used generalized additive models to try to understand the drivers of debris loads across these sites. And so astronomical season ended up being one of the model variables that explained the debris loads that we were seeing. And so here we're looking at the model predicted seasonal trend over time with the number of items per 100-meter length of shoreline on the y-axis. And at these Greater Farallones sites, we found higher plastic debris loads in the winter, so this purple dashed line, and in the spring, which is the green dashed line, which corresponds to when we expect to have downwelling conditions, so winds coming from the south, which tends to keep debris pushed onshore, and also corresponds with the rainy season in the region. So kind of a double whammy for debris loads. And so another interesting finding is that the number of participants on the survey was another variable in the model that explained variations in debris loads. So the figure here is showing the number of people assisting, or the number of participants on the survey, versus the model estimated item count deviation from the mean on the y-axis. And so the red lines here are the 95% confidence interval. And so we saw this slight increase in the expected debris load with more participants, up to a threshold of about 4 to 5 people, after which it really levels off. And so we had two hypotheses for what's happening here. It could be that sampling is more thorough as the sampling areas overlap when more people are present. Or it could be that when you have more participants, the amount of area that a given individual has to search is smaller, which limits the distance from the participant to a specific debris item, which then, of course, makes it easier to spot. So this is a bias in the data set, which would make it hard to compare debris loads across surveys and then across sites if we have different numbers of participants on those surveys. So a question, kind of a question for this group that I'd be interested in discussing is, whether there have been any similar studies looking for a similar effect in any of the trash monitoring that's being done in inland environments. So, there's a lot of receiving water and urban debris monitoring happening, especially, here with the trash amendments. And so just one last kind of data story, also from the Greater Farallones. So these survey teams on their surveys started noticing debris from oyster mariculture. So both the images at the bottom right of these mesh grow-out bags, as well as these plastic tubes that are used to separate the oyster racks. And so they started tracking them as what we call a custom item within the standard MDMAP item list and hierarchy. And so I think Hillary's going to elaborate on that a little bit. So they started tracking these items, and coincidentally, about midway through the 7-year monitoring effort, and after a lot of controversy and a long legal battle, the only oyster farm in Drake's Estero closed down in December 2014. And so here we're comparing data. So this is data from the Drake's Beach East site, which you can see here, and we're comparing the number of oyster farm debris items per survey in the period from when the farm was open and then after it closed. And so we did see a significant decrease in oyster debris after the closure. So there was about a 37% decrease between comparing July 2012 to December 2014 compared to the period when after the farm closed. And so going back to the timeline I shared, if you remember, we kind of followed up some of these data analysis efforts with a study to take a closer look at our protocol. So in 2018, we partnered with COAST, the Coastal Observation and Seabird Survey Team out of University of Washington, to address some questions about the factors that influence debris counts, as well as the detection of debris items on the shoreline. So, as you can imagine, just because an item is present on a shoreline doesn't mean that it's necessarily always going to be counted by the survey teams. And so some of these things are things that we can control, and some of them are things that we cannot control. And so we were wondering how detection varies as a function of the distance from the surveyor to the item, as well as the number of participants on the survey. And so those are things that we can control, as well as the characteristics of the substrate on the shoreline, as well as characteristics of the debris items themselves, which again are things that we really can't control. So Coast, for this project, did some field trials in Washington State where they seeded beaches with known quantities and types of debris and had different numbers of participants follow different walking patterns to survey a site. And so what they found is that less of the debris items were detected when there were fewer people and when people were standing farther than 2.5 meters away from an item. Sorry about that. So I think I was saying, that another kind of factor that led to lower detection of debris items was when a surveyor was having to walk in one direction and scan the beach on both sides of them to detect debris. And then in terms of the characteristics of the debris items themselves, Coast found lower detection rates for items that were brown, gray, black, or small, or in areas that had either a cobble substrate or were vegetated, which makes sense because those items can hide better in those habitats. And so another question that we were curious about was whether the removal of debris impacts future debris loads when a survey team comes back a month later to do the next survey. And so without going into too much detail on the old protocol, our transect method historically has said that debris should actually be left in place during surveys because we were concerned that it would affect debris loads during future surveys. And not surprisingly, we got a lot of feedback from our partners on that. So this is something else that we asked Coast to test as part of this study. And so they set up 4 different field sites. Each one had 4 sets of paired 5-meter transects. So at one transect, debris was removed, and at another one, it was left in place. And so those sites were surveyed monthly for 18 months, and they found no statistical effect of the removal a month later. And that includes even in the back kind of vegetated part of the shoreline, where you would expect debris to have a longer residence time. And so then, there are kind of some caveats to keep in mind. This was, under a survey interval of doing one survey every 28 days. And, we think that there was just enough overturn of debris during that window, given the impacts of debris moving on and off the shoreline from tides and winds and other cleanup efforts. But if you have a shorter survey interval, or you're at a remote site that's less dynamic, or if you're cleaning a much larger area of the shoreline, you might get a different result. But all in all, this was a good result in terms of being able to loosen up this rule for our MDMAP surveys. And moving forward, it'll be left up to the survey team whether or not debris is removed. And so with that, and I'm going to turn it over to Hillary to talk about what's new and what's next for MDMAP.
Thanks, Sherry, and hi, everyone. So I'm excited to share with you that we have hot off the presses an updated version of our survey materials, which include a guide, which is essentially the protocol that folks use to conduct a survey, and the data sheet. And these can be accessed on our website at the URL that's listed there. These updates reflect the lessons that were learned, both from the data analyses and studies that Sherry described, as well as years of feedback from both participants and other stakeholders and data users. So we hope you'll check it out, and we're happy to work with folks who may want to integrate these methods into their own monitoring efforts, and we certainly welcome feedback as we will be continuing to update and adaptively manage for years to come. Well, this image should be how to do an MDMAP survey at a glance. So it includes setting up a 100-meter long shoreline site. So our methods are shoreline specific. I think you probably picked up on that, which can include a variety of different types of shoreline, riverine, ocean facing, lake, but typically either sandy or sort of cobble rock. And it's ideal to conduct surveys over time. So regularly, that could be monthly or other intervals depending on the goals. And one-offs are okay, especially, and can be informative, especially when they're done in combination over a large geographic area to get a snapshot of debris loads in time. And we think it would be really interesting to compare upstream methods and results based on these updated methods. So here's an image of a 100-meter shoreline, just a schematic of the overall sampling method, where that 100 meters is fixed, and during any one survey, only 1/5 of the site itself is searched and cataloged for debris items. And those search areas are 5-meter transects that are randomly selected each time to get a sense of both the patchiness within the site as a whole and to capture a smaller search area so that at one time an individual who's searching is only looking up to 2.5 meters away from them. So it gives a standardized search area for comparability across sites and across surveys over time. So this is a really cool diagram. What it demonstrates is the search area. So participants search the perimeter of the transect, and again, they're only ever searching up to 2.5 meters from them. So that's the distance that we found items could consistently be detected on different substrates and for different sizes and debris colors to make results comparable. And because farther away, there's a significant drop-off. And we actually limit the number of searchers on a given transect. So it's 1 or 2 folks that are walking the perimeter. But larger groups can participate in a survey. They just divide across multiple transects, or they split up into different tasks. It can be a data collection group and a cleanup group, for example. And we actually introduced a separate tally of items that are found in the back barrier following the results that we had in the previous study about the impact of there not being a significant impact of removal, which actually contradicts some other recent studies that suggest that the back barrier and vegetated kind of component of a shoreline could be a significant sink of shoreline debris. So we've introduced the ability to track those items separately to get a better sense of those trends over time. And again, it's compatible with cleanups, so survey teams can make a choice about whether they're going to remove debris, and that information is collected during the survey so that it can be used in future analyses as a variable that may be affecting debris loads over time. And we have invited folks to take photos during their surveys, composite photos of all of the items that they find in a transect with a ruler for scale. And those images can be used to verify item classification and could also form a training data set for future machine learning projects for automatic item classification. So along with the updated methods and survey materials, we are soon to be launching an updated database and corresponding user interface. It has a whole bunch of really cool built-in tools for partners to ask and answer their own questions of local concern, while simultaneously contributing to a larger national data set, national, growing, international. And so it's aimed to be more user-friendly. The last major update was almost 10 years ago, so there's been a lot of advancements, of course, in software and data collection and visualization tools. For those of you who are sort of tech-savvy and interested, the data are stored in a database that's hosted within a larger NOAA repository of geographical information called Diver. And it has an API that allows anyone with access to the internet to interface with and utilize our data in their own applications and visualizations and data models. So it can automatically be pulled. It can also be posted to our database using those other applications by integrating this API framework. The new interface also has responsiveness, so that opens up the possibility of mobile data collection. Although it's not a native mobile app, it is usable on a phone or a tablet or a computer. So in addition to having the paper data sheet options, some of our participants prefer one over the other. And then I really want to highlight a couple of different things, the customization and the data visualization features. So in the data viz standpoint, we've got a couple of different ways that we are providing tools for users to be able to interact with the data set without having to have their own software to look for trends in their monitoring efforts. So we present composition data using a sunburst chart that can be viewed at the survey level. So looking at material types and item types as a proportion of the whole at either the survey level, the site level, so across all data that have been collected at a selected site, or across a set of sites that have been selected. So for example, you can look at composition across all sites in California over all time. And then we also built in time series data to be able to look at loads of debris on the shoreline in a monthly snapshot. Again, either at the site level or as an aggregation across a selection of multiple sites. And these debris load time series can be viewed either across all debris types or by selecting a subset. So I'm just going to dive into a couple of examples now. So Sherry mentioned in MDMAP, items are classified according to both material and item type using a standard list. And so what you see here, the inner ring is material type and the outer ring is item type, so subsets. So the big purple is plastic, no surprise there. We're looking at here just a single site's data. So if you were interacting with the site, which you'll be able to very soon, as you scroll over the sunburst chart, you get a live read of the proportion of the total for either the material or item types, and you can click on them. So if you were to click on plastic, for example, that zooms in to the various item types within plastic. And so you can see Sherry presented this earlier in a different way, but hard fragments are the number one item at this site. So that's taking up almost 50% of the total plastic. And sub-item types are visible here as well. So in this case, you're looking at plastic, other, and then you can see within other, there are sub-item types of the item type of plastic other. And this is where the custom items show up. So sometimes that kind of fixed list that is applicable at a national to international level is not as specific as our partners are interested in at a really local level, where there may be items of particular concern for specific sources that should be tracked. And so here's the oyster spacers and oyster bags, which we can see at this site contributed 3.7% of the total items over time. Other examples of that sort of specific type that people track as subsets of our other item types include specific net types or rope types attributed to local fisheries or buoys or local crab trapping operations and things like that. So what's elegant, I think, about this is that they're subsets of our parent categories, which allows the data to be comparable over a larger set of information, but also gives the resolution that local partners are interested in for their particular interventions and prevention efforts. So in terms of time series, this is another example from a single site looking at all debris. So we present items per 100-meter length of shoreline, which is scaled up from the 4 transects that are sampled. So the blue dots represent the average number of items seen on a 100-meter length of shoreline, running from that back barrier to the water's edge. The back barrier data are treated separately because that's a new part of the data set. And the blue wash represents the standard deviation, so the variability. And each dot is a single month in time. And then gaps along the timeline denote where there were no data. The prior example showed you all debris, but you can select according to specific item type. So again, you can pick your custom item and see if it's changing or over time, or any of the standard item types. So here we're looking at bottle and container caps over time. So you can see the potential here to evaluate trends before and after a particular intervention, like a policy change or a change in local activities. Or if you're looking at a global data set, whether we're having a reduction in marine debris over time. We're really hopeful that you'll keep an eye on these updates, check them out, and let us know what you think. And at this point, we're happy to answer any questions or discussion. Thank you.
Thank you. Participants are allowed to unmute their phone, ask questions. We also have the chat function, so you can send your questions in via the chat. And while we're waiting for folks to send us their questions, how is the Marine Debris Tracker app going? It was shared on SciStarter quite a long time ago with, I think, a origination date of 1995. Has that been updated? Is there something new that we should be looking forward to receiving from y'all regarding the Marine Debris Tracker app?
Yeah, so the Marine Debris Tracker app is a mobile app of the University of Georgia. And the initiation of that effort was through funding in part from the Marine Debris Program, but it's not actually our initiative or project.
Okay.
It does. It's an opportunistic data collection platform, so it's based on counts at a geo-referenced location. So it uses the phone's internal GPS to be able to get a GPS point for each item count that's input. And the platform incorporates really any list that anyone wants to build into it. And so it has the shared list from so the Marine Debris monitoring and assessment project list is in the Tracker app, so people can use that same list to do opportunistic data collection if they're interested in doing that. And in the future, we could potentially try to compare the data sources because they can talk to each other through that common list. But because the methods underlying there aren't methods associated with the Tracker app data unless someone chooses to use a protocol along with them. The underlying data are really in a different structure, and so that's there has been some confusion around whether these are the same thing or not, but they really aren't.
Okay. Yeah. Under NOAA's mobile resources, they have it listed, so I just wanted to get some more clarification. I get those questions a lot. And then the protocols that you discussed today, the new ones under the MDMAP, how can people get the electronic forms for their tablets? Is it just a matter of downloading the PDFs and modifying them, or how can people get the correct survey tools electronically?
Thanks for that question. Yeah, so the files themselves can be reached on the website and downloaded and printed or not. But in terms of inputting data mobily on your tablet, it's through our database site. So
Okay.
that is what is being updated and will go live in May. So the prior version of that site required a login in order to explore data or enter it. Basically you'll go to our existing URL, and when we update it, it'll suddenly look really different and more modern, and you won't have to sign in order to explore it. But in order to add data, you would create a login and walk through the interface to add a site and a survey.
I think so. Zoe?
Yeah. Hi, good morning. Hopefully everyone can hear me. I'm Zoe Scott. I work with the City of San Diego Public Utilities Department. And I actually used to work with Heal the Bay, so I'm very familiar with how the database website used to look. But it was a super powerful tool when we were there. So thank you, Sherry and Hillary, for your talks today. This is really exciting stuff to hear about. I have kind of a two-part question that one or both of you can maybe help answer. So since we're in the San Diego region, how can we figure out if there are already surveys taking place in our region, just so we're not duplicating efforts?
That's a great question. I can try to take that, Hillary. So I think, an easy thing to do is to reach out to us, and we'd be happy to kind of give you some background on active participant or active organizations in your region. I can tell you now, I don't think that we have any active participants in San Diego at this time. But also on the database, on the homepage, you can see a map of all of the sites that have been established, and whether or not they're active, like sort of what when the most recent surveys have been submitted to those sites. And there might be an opportunity there, and we can sort of work with the folks that were previously surveying those sites to sort of adopt those and continue to expand sort of an existing data set rather than establishing a new site. So yeah, the best thing to do is to reach out to Hillary or I, or we have a generic email address that goes to our MDMAP team, which is just md.monitoring@noaa.gov.
Awesome, thank you. I'll definitely follow up. And then my second question, so the city's ocean monitoring program has monitoring that occurs both along the shoreline with weekly water quality sampling, as well as offshore at a number of sites for water quality sampling among other sort of community sampling techniques. And I'm wondering, there's a standard protocol now for shoreline sampling, but is there anything in the works, or have there been talks of any sort of offshore monitoring techniques?
That's a great question. Hillary, I can try and take this one too. So we have, we don't have sort of a similar citizen science program spun up, or a database for accepting and sort of housing the offshore data. What we can offer is from back in 2012, we published it's a NOAA technical memorandum on marine debris monitoring in a number of different compartments, and so it outlines sort of our the shoreline survey protocols at that time. It also outlines a trawl survey protocol, as well as an at-sea observer survey for larger floating debris items. So at this time, we don't currently have plans to expand into other compartments. I think, for now we're focused on getting the shoreline monitoring program sort of as robust as it can be. But yeah, good question. Something to think about for sure.
Yeah, exactly. And we do monitor during our trawl monitoring, as well as every 5 years we are part of the Southern California Bite Monitoring Program, the regional program. So I know that that's one of the arms of our monitoring, but maybe that's something we can continue conversations about to see if there's ways we can sort of standardize how we're gathering data, or better gather that data to answer the kinds of questions we're trying to ask the data.
Exactly. Yeah. Thank you. It looks like Pilar has a hand raised.
Hi, yes, I was just wondering if you've, I'm sure you have, but what your thinking might be in terms of where the debris that is found on the shorelines is coming from. Is it maybe coming from the ocean or from nearby rivers? Any thoughts on what the implications for beyond just cleaning up the shoreline? How could we prevent debris from getting either to the shoreline or to the ocean itself?
Hillary, I'll let you take this one.
Goodness, that's a huge question. And it's absolutely kind of underscores the purpose of the monitoring. It's really hard to identify the source of a single item on the beach, whether it came from a river or washed up or was left behind by a beachgoer. But the intent here is that by tracking particular indicator item types, so we know, for example, fishing related gear is coming from the ocean and was lost likely at the ocean, and consumer type debris, single use items, are more likely to come from beach going users. So depending on the composition of what we and the pattern of that composition of items that we see over time, that can indicate something about the source of what we're seeing on a beach. So what we see on shorelines indicates something about what the sources of items are in the ocean. It's a little window, basically, into what's happening in the ocean. And those patterns that we see can help us prioritize prevention and reduction efforts. So, for example, if we see, like in the story that Sherry shared, a lot of our partners will identify a particular item or items that are contributing to the composition of what they see on the beach, and that data have formed stories that have then informed the interventions. So whether it's a policy change or a local education campaign about reduction of those item types, that's kind of the relationship between sourcing and the data set. But it would be, I think, one message that we did want to get out there is that it would be really interesting to compare these data to some of the more upstream monitoring efforts that exist, knowing that rivers and storm drains and wind and all of those things are important contributors to what winds up in the ocean. I hope that it's a big question that we could devote a lot more time to, I think. And I'm glad you guys.
Yes, thank you for that. Appreciate your thoughts on it.
It looks like we have time for one more question.
Adriana has a hand raised.
Hi, thank you. My name is Adriana Stovall, and I work with Larry Walker Associates, and I manage a couple of trash monitoring programs in the Southern California area. And I know that you said you weren't a regulatory agency, but are you sharing your monitoring protocols and your standardized methods for monitoring marine debris with any regulatory agencies or public entities so they can improve upon their existing monitoring programs?
Yeah, that's a great question. And so, our protocols and our data set are all publicly available. And, I think this is kind of one of the first venues we've had to kind of share the outcomes of the coast study that I talked about, where we did sort of see this effect of, the differences in walking patterns and the impact that the number of participants on the survey really has on debris detection, which I think is, it is probably something that should be considered in, especially, for the monitoring that's happening as a result of the trash amendments, to kind of inform, sort of what is the impact of all of the investment that's being made in this trash capture infrastructure. So, I think the answer is that's something that we're definitely interested in and really happy to do. So if you have any ideas for who or specific contacts that we should be reaching out to, and I know the trash monitoring work group is certainly a great start, and we're involved in that, and so I think that's a good venue for us to continue to share these resources too.
Great, thank you.
Yeah, thanks.
Yeah, I would add to that as well that the data itself are also publicly available and could be used by regulatory agencies in their work and meets the standards to do so. So, in addition to the protocols.